Hi guys. So this is the point of the year where we're going to learn some really simple Grasshopper. So Grasshopper basically is a visual scripting element for Rhino that makes Rhino modeling parametric. So you do have to download it, and I think the computer lab has it already pre-installed. So we're more than likely going to supply you with definitions that you'll use, and obviously you're more than welcome to modify them as needed. So within these Grasshopper tutorials, I'm going to build very simple steps that you guys can kind of learn from, but we are going to supply the definitions for you. So basically Grasshopper, if you have Rhino open, it's a secondary plugin for Rhino, and there's also plugins for Grasshopper within Grasshopper, so it gets a little bit confusing, but you get the hang of it. So in Rhino, if you want to load up Grasshopper, you basically just type in Grasshopper, and it should come up. You'll end up with a screen like this. So this is a Grasshopper canvas here. These are all your parameters here, and I'm not going to go through them. You can start to do math in here. You can do some really heavy scripting, and also make some really crazy, wacky looking stuff relatively fast. So basically, if you think about Rhino and Grasshopper, you're building a Rhino model through a set of parameters that are parametric, and you also can feed back geometry to Grasshopper. But for today, we're going to make a lofted shape and then contour it. So first things first, getting started, if we want to make a rectangular lofty shape, let's start out with just making a simple rectangle. So if we double click into the canvas and type in rectangle, just like you would do in Rhino, and we just click on one, we end up with a plug like this. So this plug has different parameters, and basically it goes through the X size, the Y size, a radius, so if you have a fillet, and then also its location in Rhino. So if we want to load in data and say we wanted to place a rectangle at that point, we'd select our point and double click into Grasshopper and just type in point, and basically we have a point in Rhino and a point little plug in Grasshopper. We want to right click on point, and as you can see it puts a little X on our point there. That means it's loaded, and we're going to click and drag this little knob into the P on rectangle. So basically that's going to create a rectangle wherever we move that point. So from here we're going to justify the size of this rectangle. So let's just double click into our canvas and type in 5.0, enter, and that makes a number slider for us. So we're able to move this physically, and then also if we double click in here, we can also type in dimensions. If the dimension's not big enough or needs to go into the negative numbers, we can double click on slider, and we can also set the max range here. So if we want to go up to 20, we can, and we're able to move it farther than 10. So again, I'm going to double click in here, just make it 10. And this knob, I'm going to pop it into the X. So from here, as you can see, if we start to move this number slider around, we start playing with the X dimension of the rectangle. Now I'm just going to click on this number slider, hit Control C, Control V, and copy and paste it. I'm going to slide this next slider into Y. So now we can play with the Y dimension. This is a very, very simple version of parametricism. Now let's say we want to add a little bit of a fillet on the side. So I'll go with a lower number, 1.25. These are not accurate dimensions, so I just make that clear. So as you can see, we can start to modify the fillet in here. Great. So basically what we're going to do today is something similar to this. So if I build this in Rhino and I put a twist on it, we can start to twist objects in Rhino, for instance. But if we wanted to twist them exactly to a certain parameter and we wanted multiple iterations, well, it's a little bit tricky and a little bit redundant. So basically what we're going to do is a loft a bunch of surfaces up to create something similar to this and also be able to generate different iterations of that movement. So for the next step with this rectangle is we're going to move it up. So in Grasshopper, you need to justify a vector for this movement up. So our vector obviously up is z. So if we type into Grasshopper z, that's our vector up. And if we hover over these little plugs, geometry, our base geometry, which is the rectangle, and we plug it in there, we can see that our rectangle moved up. So by default, the motion is set to z, but we need to plug the t into this z. And so if we put in a number and we just copy and paste or type in a new number, we're able to see that we can move that rectangle up and down. So now let's say we wanted multiple curves that justified our loft going up. So we'd create a series of different heights that we want our rectangle to sit at. So basically, it's just as intuitive as Rhino is. If we type in series, that'll give us a series of numbers. So if we hover over here, the first number in series is 0, which it would be our first one. And if we go to n, it'll say step size. So that's the distance in between the series of numbers we want these rectangles to go. So let's just do 5. If you guys are playing around with the definition, don't be afraid to just start messing with these sliders. And then the C is the count. So how many rectangles do we want to go up? So let's just do 7 for now. There. So, and then if we hover over here, it says 7 locally defined values. So we have 7 numbers and they're 5 inches apart. So why don't we see any rectangles going up? Well, we need to put this S, the series of numbers, into our Z vector. So that gives us 7 curves, and we can change it to however many curves we want, and we can also change the size in between them. So what we can do from here is start to add rotation on these curves. So if we double click, type in rotate, and you got all these different rotates, but for now we're just going to do rotate around a plane. Basically from here, we're going to do our G to G, and then we're going to right click on the A. So, and we're going to switch this over to degrees. And now, if we double click here and just type in 180, for instance, and plug it into the angle, you can see that our curves are rotating. Pretty crazy. So, as you can see, it's rotating around its 0, 0 axis. So that's because we haven't justified a plane. So to justify a plane, and say we want to make the plane center to each one of these curves, I'm going to type in area. And I'm going to take the G, plug it into the original rectangles that we moved up. And basically that gives us 2 outputs. One is area, and that tells us obviously the area of those rectangles. And the next is a centroid. So if you guys haven't learned in structures yet, a centroid is the center point of a moment beam or the exact center of an object. And basically, we're going to define this plane as the center of these objects. So if we plug the C into the P, we can start to see that these rotate around the center. Now again, what if we wanted to make these all turn, say, 5 degrees here, 10 degrees here, 15, 20, and so on, and start rotating kind of incrementally around this axis? It'd be a series of different angles. So a series of different angles, obviously we're going to need another series here. So if we just scroll and kind of hover around and select these and copy and paste them over, basically what we can do is just click and drag this S over to this A. And basically now we set up a bunch of rotations that are incremental to one another. Now, if you don't like getting confused by the original moves, basically we can select the ones that are highlighted in white, and if we hit spacebar, we can turn them off, or hide them basically. Okay, and we can start to delete out and clean up this definition a little bit. So basically, as you can see here, we got a series of rotations around the center axis. Now let's say we wanted to make that step size a little bit bigger. We double click on our little slider there, and let's just put in 90 degrees as our step size for the maximum. Now let's play with these again. So as you can see here, we can start to get some pretty crazy rotations. And now let's just do a little check of our work. So if we double click in here and type in Loft, and click on our first Loft, and plug this C, which stands for curves, into the G here, we get some geometry, which is pretty cool. And just the same as Rhino, having capped holes is always good, as long as it's planar. We can just plug that into here, and let's hide the Rhino, or the Loft. And basically we have some geometry here. Again, we can start to play with how that geometry starts to look. Now you guys can add in a scale or any sort of thing like that, which could start to influence this design quite a bit more. So as you can see, we can start to add these really cool corkscrew moments. And then also, what we can start to add some variation to is which curves we're actually affecting. So currently, we have 10 curves that are getting moved up to create our series of curves. So let's just say we wanted to only affect 3 of these curves in the rotation. So the count currently is at 10, so it's affecting all of them. Let's just move that down to, let's just do 4. So we get this really beautiful looking, just formal strategy here that only moves 4 of the curves. Let's just bring it up maybe, or down. So again, we can start to limit these a little teeny bit and rotate again. Now, if you wanted to select this geometry, obviously it's not real yet. It's not existent, it's just a graphic. So if you wanted to take this geometry and actually have it in Rhino, what you do is either hit any of these plugs and you can get the data, but let's say we wanted the surface. Let's select cap and basically hit spacebar, hover over this egg, and it'll say bake. Basically, that gives us Rhino geometry. Right there. Now say you didn't like that one, but you wanted to compare it to another one. Now let's add a few more curves in here. Just mess with some settings. Maybe we need to make it a filleted version, and that rectangle needs to be slightly larger or smaller. So each one of these little numbers that we set up are parameters within this definition. Basically from here, you can hit the cap and bake that again. So now we have another variation of the same definition with different geometry. So this is really helpful for getting out multiple iterations really, really quickly, especially if you're in a design jam and need to work fast. So there we go. So now we have 3 different variations, 3 formal strategies in less than 5 minutes. So from here, if you wanted to contour this model, type in contour, and we're going to go with this contour, which is create a set of B-rep or mesh contours. Basically from here, we're going to put the S into our capped object, and then here it's going to be define a vector, which we want to go, let's just say in the Z for now. Now if you guys want to do an X or a Y, I'll make different contours. And since I didn't dimension this object necessarily perfectly, we'd put in how thick our materials are. So let's say I have a 5-inch piece of wood that I want to contour up, or I want to bring it down. This is all parametric. So as you can see, the contours start to move by the distance in which my material is. It automatically makes your contour section here. So from there, if you want to visualize it slightly, we could type in extrude. And let's put it on our Z vector, because we want to extrude up. Basically, we can just plug in this Z, since our distance from contour to contour is 0.8 in this example. We can just plug this number into there. So they share plugs. So as this updates too. So as you can see here, and we want to cap these as well. And let's just turn off the contour and extrude so we get a nice clean visualization. Basically, if we start to move this, our extrusion starts to line up and they update automatically. So you guys can start to visualize what size of material you want to use. Now say, oh shoot, I got to change the rotation because something's not right. Well, that's fine. The contours still update and you're still stuck with the same formal strategies. So each one of these operates independently of the other, but they're also dependent on the end goal. So I hope this first tutorial helps out and wish you guys good luck. And please just mess around with the Grasshopper definition we give you and just see what happens.